In the early 2000s, geneticists set out to map the DNA of every population on Earth. Hundreds of samples, dozens of groups, one shared route reaching back to Africa. Branch after branch, it locked into place. Every population found its spot on the tree, clean branches, clean splits, decades of fieldwork finally converging on one diagram. Except one. A few hundred people lived on a chain of islands so isolated their language matched nothing around them. And they carried something the model simply couldn't explain, not extra DNA. A gap sitting exactly where a match should have been. Somewhere between the roots and the branches, one people had fallen straight through the map, not lost. There was a reason for the gap. Nobody in that room knew what it was yet. It would take 3 separate discoveries, a decade apart, to explain why. For 2 centuries, outsiders had their own explanations. European sailors saw dark skin, tightly curled hair, and reached for the nearest one, shipwrecked Africans, blown off course and stranded for good. Anthropologists had a second idea. Living fossils, the first humans out of Africa, frozen in place, while the rest of the species kept moving. Both stories sounded confident. Both were built on nothings but appearance. Neither one survived contact with the genome. The islands are the Andamanese in the Bay of Bengal. 4 peoples live there. The Great Andamanese, the Onge, the Jarawa, the Sentinelese. Different languages, different histories, never one tribe. The decisive samples came from the Onge. Their maternal and paternal lines gave the first hard answer. No shipwreck, no recent African arrival. Their ancestry reached back to the very first wave of modern humans who ever left Africa. 50 to 70,000 years ago, deep enough to sit near the root of the whole human tree. The living fossil idea held on a little longer, until geneticists remembered something obvious. Isolation doesn't freeze a genome. It just lets chance run wild inside it. One rare lineage spreads through a population in a few generations. Another disappears completely, and nothing ever sits still. Not even on an island nobody visits. In 2010, in a cave in the Altai Mountains of Siberia, researchers built a full genome from almost nothing. A single finger bone, smaller than a coin. It belonged to a species no one had known existed. They called them the Denisovans. A handful of teeth, a jawbone found later in Tibet. That is the entire fossil record of an entire branch of humanity. Everything else we know lives inside the DNA of people alive right now. So researchers went looking for it, near the cave across East Asia. Barely a trace. A fraction of a percent, easy to miss. The strongest Denisovan signal on the planet turned up 5,000 kilometers away in Papua New Guinea, in Australia, across the islands of Melanesia. Some people there carry 6% Denisovan DNA in their genome, more than 20 times the level found anywhere near the cave. Something had happened in the tropical south, and it had nothing to do with Siberia that put the Andamans directly in range. First wave ancestry, sitting on the route east, right where the archaic signal ran strongest across the whole southern arc of Asia. If any living population had absorbed it, logic said, it was this one. Researchers ran the comparison, certain of the answer. Before the results even loaded, nothing came back. The position where a match should sit stayed completely empty. The analysis had finished, and there was nothing to report. The Onge carried no comparable trace of the Denisovans, and the absence solved something a match never could have. The ancestors of the Onge and the ancestors of the Papuans had once shared a single root in eastern Eurasia. Then they split. Only afterward did the eastern branch meet the Denisovans and carry part of them forward into New Guinea, into Australia, into Melanesia. The gap in the Onge genome gave researchers something simpler than a mystery. The order of events, The split came first. The Denisovan contact came later on a branch that was never theirs. Then, in 2018, a separate team reran the analysis on Papuan and Australian genome. Same question, and yet a different answer than anyone expected. Not one Denisovan population, but at least two separated from each other by hundreds of thousands of years before either one ever met a modern human. One matched the Siberian cave. The other had never been found anywhere. No cave, no bone, no name, only its DNA, still folded inside living people on the other side of the world from where the first Denisovan was ever identified. Two extinct species, one fossil record between them, and it barely fills a shoebox. So where does that leave the map? During the Ice Age, falling seas joined mainland Southeast Asia to Sumatra, Java, and Borneo into one shelf you could walk across. Further east, deep water never closed. The boundary naturalists later named Wallace's Line. No single beach explains the meeting, or which Denisovan population it involved, but the order is settled. The Onge-related branch had already split off before the major Denisovan contact recorded in the East Geography and Genetics, telling the same story from opposite directions. And that's what it actually broke the tree. Branches were never supposed to reconnect once they split apart, but populations did exactly that. Again and again, leaving fragments of themselves inside each other before disappearing entirely from the fossil record. The Onge were never an exception, standing outside the model. They never broke it by refusing to fit. The model broke because it had drawn fixed lines across a history that never once stopped moving. Their tie to South Asia is real, so is their tie to the Papuans, both true at once the rigid boxes come off. The genome explains none of what colonization did. When Britain took the islands in the 1800s, disease finished what centuries of isolation never could. The great Andamanese fell from thousands of people to a few dozen within 2 generations. The Sentinelese were never sampled at all. No result from the Onge can be pinned onto them. They remain deliberately the one population genetics has never touched. In 2018, an American ignored the law, reached their beach, and was killed within hours. After the 2004 tsunami, a helicopter went to check whether anyone had survived. One man came out onto the sand and fired arrows into the sky. No camera crew, no rescue team, just that single act, filmed from a safe distance and never repeated. He wanted to be left alone. For now, that is exactly what keeps his people alive. Every explanation that came before the genome got the shape of the story wrong. What the Onge actually carry is smaller than any of it, and stranger, a shared root with populations who kept moving, and a gap marking exactly where their paths split, before those populations ever met the Denisovans, before science even knew there was more than one Denisovan population to meet. That's the order it actually happened in. A shared root, then a split, then contact, but only on one branch. The gap in their genome was never empty. It is the clearest mark on the entire map, proof of exactly where one road forked from all the others. Moments before science met a species it hadn't even known to look for, the Denisovans.